See, now first of all we are starting with the derivation of law of conservation of energy, that is for a freely falling body. Suppose these are the three positions of the body. Initially the object is at position A, then somewhere in between the object is at position C, and then finally it reaches the surface of the earth, that is at position C. This is the object whose mass is m. Okay, I'll consider the total height of the object from A is h.
A to C.
Yes. Then from here to here, okay, this height is x. So obviously distance AB will become h minus x. Okay. Now at all three positions A, B and C, we will find the sum of kinetic energies plus potential energy. Okay. So we will consider at position A, we will find the sum of KE and PE. At position B we will find that, and at position, yeah, so in all three cases we will prove that the total amount of energy in all three cases it is equal.
Yeah.
Okay, so all three places the total sum of kinetic energy and potential energy remains the same. That is law of conservation of energy.
What's the law of conservation of energy?
Law of conservation of energy, the statement is the total amount of energy in the universe always remains constant. Yeah, energy can neither be created nor can be destroyed, but the total amount of energy in the universe always remains constant. Now in this particular example, see, when the object is falling from the position A, initially when it is at this position A, it just starts falling down, so it is having only gravitational potential energy. At that time its initial velocity is 0, so its kinetic energy will be 0. Okay, so we start calculating the sum of kinetic energy plus potential energy starting from A. Now at A, initial velocity, that is u, is 0, so its kinetic energy, the formula is half mv square.
Yeah.
There will be half m into 0 square. Its kinetic energy at point A becomes 0.
So what's m, so the
mass?
what will be the mass of it?
Whatever it is, we have just yeah, it's not 0. Mass is not 0. Mass is m, whatever the mass may be. Okay, its kinetic energy at position A is 0 because its velocity is 0. It just starts falling down. Now we have to find the potential energy at A.
mgh.
It will be mgh. So now at A, KE plus PE, this is equal to, at A kinetic energy is 0, and its potential energy is mgh. So sum of,
separate?
you can if the values are given. So 0 plus mgh is how much?
mgh.
So sum of kinetic energy plus potential energy at which point? At A
mgh.
is mgh. Now we take the second point, that is B. Okay, now at B what is the height? The height is x. Okay, and we also have to find the velocity at B. From there we will get the kinetic energy. Okay, so now we are considering at B. At B, its potential energy will be mg
x, okay.
x, because the height is x. Now we got to find the kinetic energy at this point. Okay, now how will you get the kinetic energy? For that you need to know the velocity. Okay, how will you get the velocity from here at this point? Okay, now see here, the distance that is travelled is this much, that is h minus x. So S is, just 1 second. See, just look at this. We have found we have to get the velocity at B. Okay. Here U, that is initial velocity, will be how much?
0.
0. The velocity at point B we are considering is V. Once we get V, that is the velocity at B, we will be able to find its kinetic energy. Now for this we are using the third equation of motion. The third equation of motion is V square is equal to U square plus 2as. Okay. V is the final velocity, U is initial velocity, A is acceleration, and S is the distance traveled. In this case U is 0, so this will disappear, it will become 0. Okay. 2 into acceleration is gravity, so it will become G multiplied by S.
H minus X.
Yeah, that is the distance traveled is H minus X. Now V square is equal to 2G H minus X. Okay, now what is the formula for kinetic energy?
Half mv square.
Half mv square. This is equal to half m multiplied by, instead of v square, what will I substitute?
2 into 2g H
2g bracket H minus X. This is the kinetic energy at B.
Yeah, got it.
Potential energy is this much, kinetic energy is this much. Now in order to get the sum total of energy, that is potential energy plus kinetic energy, I just have to add this and this. So the total of kinetic energy plus potential energy, that is Ke plus Pe, is equal to, I will be adding this and this. Okay, its kinetic energy is half m 2g H minus X. Now the potential energy, which is this,
mgx.
this is equal to, now half m, just open this bracket, this half and this 2 will get cut. I can skip this part, okay, because it is getting cut over here. This 2 is got, mg, it will become h minus sign mg, it will become x, and then plus, which is this part. I can straight away cut both of this.
mgh.
The sum total of kinetic energy plus potential energy even at point B is mgh, which is same as the sum of kinetic energy plus potential energy at A. Now the same thing we will prove at C. Can you tell me at C what will be its potential energy? It will be 0,
Will be 0.
because height is 0,
0, yeah.
because it is touching the ground. So at that point at C, height is 0. Okay, so now we will consider the sum total of kinetic energy plus potential energy at point C. So at C, whatever is simpler, that we will write first. Its height is 0, therefore mgh, that is potential energy, will become 0. Now we got to get the kinetic energy. Kinetic energy, the formula is half mv square. Now again also, here also we will get v square is equal to u square plus 2as. U is 0, 2 into acceleration due to gravity is g. Now at C, distance traveled is going to be its height.
Okay, height.
This is equal
But I
to,
thought it was 0. Height was 0.
its height is 0, but if I am considering from A to C how much distance it has traveled,
Then it's h.
then it's h. It's not 0. Distance traveled is not 0 from A to C. Okay, so it is going to be h, because we are considering here the distance traveled, s means. So it becomes v square is equal to 2gh. Now kinetic energy, the formula is half mv square, that is half m, this v square will be substituted now by 2gh. Cut this 2 to, what do we get?
mgh.
Now the sum total of potential energy plus kinetic energy at point C. Its potential energy over here is 0 plus its kinetic energy is mgh. This will give us mgh. Now from all 3 points you can see at C also the sum total of PE plus KE is mgh. From the previous part you can see the sum total of kinetic energy plus potential energy at B is also mgh. Even at A the sum total of kinetic energy plus potential energy is mgh.